going to learn about how to find the difference in areas. Let's say we have to find the difference in areas between the shaded portion A and the shaded portion B. Before we start solving this problem, let's first write down some basic facts about this problem. First, we can see in this problem that there are 3 semicircles. This is the first semicircle, this is the second semicircle, and this is the third semicircle. Let's name these semicircles E, F, and G. This is semicircle E. This is semicircle G, or F. And this is semicircle G. We can also see that the centers of these semicircles, this is the center of semicircle E, the center of semicircle F, and the center of semicircle G, all lie on the same straight line, which is the base of this rectangle. Let's name these centers as centers O, P, and Q. This is center O. Center O is the center of semicircle E. This is center P. Center P is the center of semicircle F. And this is center Q. Center Q is the center of semicircle G. We can also see in this problem that all the semicircles have the same radius, which is 7 centimeters. So let's write down that R is equal to 7 centimeters. R is equal to 7 centimeters. Now let's start solving this problem. So, we can see that if we draw a line from point Q, center Q, all the way up to the top of the rectangle, let's name this point as point R, and we draw a line from point P all the way up to the top of the rectangle, let's name this point point S, then we get a square. This square is square PQRS. We can verify that this is a square because the side PQ measures 7 centimeters, the side RQ measures 7 centimeters because the height of this rectangle is 7 centimeters. Side SR measures 7 centimeters because side PQ measures 7 centimeters, and side SP measures 7 centimeters because the height of the rectangle is 7 centimeters. Now, we see in this square that the 2 unshaded portions, which are here and here, are equal to each other. This is true because in this diagram, each of the semicircles start on the center of one semicircle and end on the center of the other semicircle. Let's take semicircle F, for instance. This is semicircle F. Semicircle F starts on center O, which is the center of semicircle E, and ends on center Q, which is the center of semicircle G. So, this means that each of the unshaded portions, here and here, are equal to each other. Let's name this unshaded portion as portion C. Now, because these portions are equal to each other in area, then this means that this unshaded portion here should be also named portion C. Now, when we add together the area of portion A with portion C, the area of portion C, then we get the area of a quarter circle. So let's write down that the area, A for area, of portion A plus portion C is equal to the area of a quarter circle, which is equal to the area of a circle divided by 4. So the area of a circle is pi r squared divided by 4, which is equal to, the problem says to use pi as 22 over 7. So which is equal to 22 over 7 times the radius is 7 centimeters. Radius squared is equal to the radius times the radius. So times 7 times 7 divided by or over 4. 7 goes into 7 one time. 22 and 4 are both divisible by 2. 4 divided by 2 is equal to 2, and 22 divided by 2 is equal to 11. This is equal to 11 times 7 is equal to 77 over 1 times 2, which is equal to 2. 77 over 2 is equal to 38.5 centimeters squared. Now let's find the area of the square PQRS. But we don't know what the side of PQRS is. Actually, we do. The side of PQRS, so square PQRS is equal to 7 centimeters. It's equal to 7 centimeters. So let's find the area of square PQRS. The area of the square is equal to the side times the side, so 7 times 7. 7 times 7, which is equal to 49. Let's write this a little bit lower. The area of the square is equal to 7 times 7, which is equal to 49 centimeters squared. Now, we see that if we subtract the area of portion A plus portion C from the area of square PQRS, then we are left with the area of portion B plus portion C. So let's find the area of portion B plus portion C. The area of portion B plus portion C is equal to the area of the square minus the area of portion A plus portion C, A plus portion C, which is equal to the area of the square is 49 centimeters squared, so it's equal to 49 minus 38.5 centimeters squared, So minus 38.5 centimeters squared, which is equal to 10.5 centimeters squared. 10.5 centimeters squared. Now, we need to find the area of portion A minus portion B. The area let's write this down here. The area of portion A minus portion B is equal to the area of portion A plus C minus the area of portion B plus C. The reason we are going to do this, I'll explain to you after we solve it. So it's equal to 38.5 centimeters squared. So it's equal to 38.5 minus the area of B plus C, which is 10.5 centimeters squared. So minus 10.5 is equal to 38.5 minus 10.5 is equal to 28 centimeters squared. Now let me explain to you why the area of portion A minus portion B is equal to 28 centimeters squared. Let me first write down 28 centimeters squared. The reason we subtracted portion B plus portion C from the area of portion A plus portion C is because portion C gets added once. Let me write down. So the area of portion A plus portion C minus the area of portion B plus portion C. So the C gets added once here, but C also gets subtracted once because plus and minus makes it minus. So C gets canceled out and we are left with the area of portion A minus the area of portion B, which is 28 centimeters squared. The area of portion A minus portion B is equal to 38.5, which is the area of portion A plus portion C, minus 10.5, which is the area of portion B plus portion C, which is equal to 28 centimeters squared. Today we learned about how to find the difference in areas. Thank you for watching this video.